Hi, everyone. Thanks so much for joining us. I'm very excited to welcome Professor Eric von Hippel to today's talks at Google. Eric is the T. Wilson Professor of Innovation Management at the MIT Sloan School of Management. He is well known for his research on user innovation and open democratized innovation. Eric is a graduate of Harvard College, MIT, and Carnegie Mellon University, where he got his PhD. And he is also the recipient of 4 honorary doctorates and numerous academic prizes, such as the Humboldt Foundation Research Prize, the EU Innovation Luminary Award, and the Portuguese National Medal of Science. True to his work on open innovation, Eric has all of his books and most of his articles available for free on the web under Creative Commons licenses. Um, Please, as we have this conversation with Eric, please feel free to put questions in the comment box, and we'll come to audience questions at the end of Eric's talk. Welcome, Eric, and I'll hand the mic over to you.
Well, thank you, Rida. And also, I must say that I really have enjoyed working with you. Rida does wonderful work on user innovation, a field of my great interest. So I look forward to more of that. What I'm going to tell you about is lead user innovation, how to find them, how to use them. Those of you who are science fiction fans will know about William Gibson's comment, the future's arrived and it's not just evenly distributed yet. And this is the case with lead user innovation, research, and practice. So what I want to tell you about is something that is not just sort of in the air and potentially coming up. It's something that has really solidly arrived, but it's in niches so far. And so the advantage here for all of us will be that it can be spread and understood at an early stage. Illustration of how it has already arrived is that the OECD added consumer innovation to its official definitions. Someone named Fred Galt was the prime mover in getting this done. As you can imagine, it wasn't easy. And in 2019, the UNDP invested $120 million to identify and support rural and urban user innovation in 91 countries. And Gina Lucarelli is the prime mover there. So we are in a reasonable scale in niches. And so what I will do in the remainder of this talk is tell you the salient aspects of this very quickly. A lot of work, thousands of papers. So what I'll do is sort of give you capsules, and then you can decide what you want to explore further. So here's the story. For about the last 100 years, economics has assumed the producers and not users are the source of product and service innovations. This is courtesy of, at the beginning, of Joseph Schumpeter, whose picture you see there. And his standard kind of remark was, it's the producer who as a rule initiates economic change, and consumers are educated by him if necessary. Producer focus. And what you have there at the bottom is an arrow often drawn for producer innovation. It's entirely commercial, begins with market research, finding needs, R&D to develop a solution, production, market diffusion, all done commercially. Now, those of us who are hackers will know that a producer as innovator's story is seriously incomplete. As you may know or may not know at this stage, long before skateboards were on the market, you had DIY skateboard pioneers making and using their own skateboards. And in fact, this is true for essentially all sports. Basically, every sport you can think of, not only the equipment for that sport, but also the rules and the process and the techniques were developed by users, not producers. So, it seems maybe that users are doing something. So we, colleagues and I work in a community, developed 10 national surveys, all in the same sort of questionnaire format. A representative survey is one that gets a sample that is the same as the sample or as the same as the characteristics of the population as a whole. And when you look there, you see that far from DIY consumers not being active and just sitting around and saying, "Oh gosh, I certainly wish I would have some manufacturer pay attention to my need," you have enormous numbers of users innovating for themselves. So, for example, the first study we did on the first line there, the United Kingdom, it had to do, we found 2.9 million people reported innovating, and then we screened it very carefully to reach that number. Now, 2.9 million people, to put that in perspective, is 100 times more than all the paid developers of products for consumers. So it's a massive, massive, massive kind of a contribution to the sources of innovation and the results of innovation. Okay, so in fact, we all innovate DIY at some level all the time because we all face novel situations all the time. All of us know that as well. So this is a proud father here. This is my daughter, Christiana von Hippel. She's pioneering the study of behavioral innovation in public health, and she is demoing. She had never caught a bird in the house before and gotten it out the window, but instantly she grabbed materials, purposed them for something else, and managed to create a bird trap that she could then put the bird out the window with. Now, user innovation then is large, as you saw in the case of the data from those studies, and it's getting steadily larger over time due to exogenous technical trends. So design costs are dropping due to low-cost digital tools. Nowadays, as you all know, we can get ourselves a design toolkit for basically zero that's about as good as a producer toolkit. Communication costs are also dropping due to internet advances. As a result, people can come from work. They're not necessarily 13-year-old kids working in the basement. They're anybody who at work is an expert. They can come home, they can bring home the tools that they have at work or the equivalent. They can communicate with others who are similarly interested, and they can innovate at a very high level. So what you see here in this small model is that basically the vertical arrow there, or the vertical column on the left, the situation is that it was a single user innovator. This was a viability zone for just one single innovator, their own resources and so on. And that's where we were before low-cost design and communication costs. But now, if you look at the bottom there, all of a sudden, people can add their efforts and you can get large-scale projects. So basically, if you see there that sort of angle, that line about the producer viability boundary as a function of project scale, what you see is that as these costs drop, all innovation opportunities are moving downward and to the left on this graph and entering areas of either individual viability or viability via collaboration. An example, obviously, of large-scale collaboration is Linux, where many people get together, innovate effectively, interact effectively. So now, it's not just toys and sports that we've mentioned to this point, it's serious innovations too. And so what you must be aware of is that users are ahead of manufacturers. They are lead users. They often have needs ahead of producers. And so what do? They innovate. So here's an example. This was the first artificial pancreas, and it was developed by patients and not by medical product producers. And it's a typical story. What happened is that Dana Lewis there had a great fear of miscalculating her insulin dose and ending up in a diabetic coma and dying overnight. Her husband there was a software engineer, And he formed with others a group of technical experts to create the first artificial pancreas. And it was remarkable. They used it, it actually put her blood levels of sugar into the right zone more 80% of the time versus basically 50% of the time for manual calculations. They then spread it to others. They gave it away. Thousands of people began to use this kind of interesting thing. What it looks like is basically that you take a continuous blood glucose measuring device, which firms supply there, you see it on the left, and then an insulin pump, which firms supply, you see it there on the right. And you connect the two with a sort of a small Raspberry Pi computer. You put in your own insulin dosage rules, and you have closed the loop. This was done, as I say, first by patients who really needed it and not by producers. This is a common situation. So, this phenomenon of user innovation, while newly studied, is not new. Users within firms and professions have always developed many of the most important innovations they needed in their fields. So here's John Haysham Gibbon. You see him there on the right. He invented the heart-lung machine for use in his own surgical practice. You see at the bottom left there sort of how it works. It takes blood from the heart and oxygenates it, cleans it, filters it, puts it back in around the heart. So it, in effect, operates as a heart and a lung machine when you are doing surgery on a patient's heart. It was needed because children in the 1930s, when he began this work, were dying on the operating table because they had rheumatic heart disease. And his neighbor's child died on the operating table, and he said, "This is enough. We need a heart-lung machine." Now, interestingly enough, basically, manufacturers he approached were not interested. And this is a really important part of the story. Manufacturers were not interested because they said, "We don't know if you can develop the operations that a heart-lung machine would require. We don't know that you can get a source of artificial heart valves, which your operations would require. So building the heart-lung machine is simply too risky for us. We'll wait around and, in effect, wait till you build it," which is very non-Schumpeterian. Far from the producer being the innovator, that producer was actively saying, "I see the opportunity, I don't want to do it." Now, why is this? The reason is that basically producers do not like small and uncertain markets. So users are forced to pioneer when it's a functionally novel product like the heart-lung machine. So the specific story with respect to John Haysham Gibbon and how it got to be a commercial product is that he created it, if you see on the far left there of that curve, basically users innovate because the manufacturers refused. He developed it, so he passed that test. He found a source of valves. He developed the operations needed to do it. And then he had success. So other surgeons heard of this who also had patients in desperate straits. Other surgeons heard of it. They said, "Hey, listen, can we come, John, to your operating room and see what you're doing?" He said, "Sure." So they came, they observed, they saw that it made sense. They said, "Hey, can we make a copy of your heart-lung machine?" He said, "Sure, here's a roll of drawings." They went home and they did it. So now you start to see the beginnings of demand in this story. It's starting to rise up that curve there. Now what happened was somebody within the community, namely a technician in a hospital who had built for his surgical department a heart-lung machine, said, "It's crazy for everybody to do this on their own. I'll start a little company." And that moved it further up the certainty of the market curve from the perspective of big firms. And then eventually, about X years later, Big firms like Medtronic came in and said, oh, okay, now we understand, we will build the machine. Now, this is not to criticize the established firms. Each firm is doing what it thinks in its economic best interest. The point is, what is missing in the Schumpeterian argument is that the beginning of the innovation process is missing to the Schumpeterian firms, and it's carried out by leading edge users. Okay, so you have this data in a number of fields. Here's an example. This one happens to be surface chemistry, and what you see again is the chemists developing this thing. 10 years after it was developed, manufacturers come in. Why do they come in? Well, the market has become obvious, as you see in the bottom, and it starts to grow. So they say, okay, now's a good time to enter. Now, another important point for you to understand is that when users innovate, they are the ones who develop the new functional capabilities, because these are the uncertain things in the market, right? Nobody knows if a heart-lung machine will do what it's supposed to do. So again, users take that on because they pioneer. Later, when the market exists, as you can see again in this curve at the bottom, manufacturers can say, well, now we can innovate too, and we will make, for example, a more reliable heart-lung machine, which everybody will want. We will make a more convenient heart-lung machine. We will make a more sort of easily cleanable heart-lung machine. In effect, what's going on here is that you have divided the job of innovation. New functional capabilities where markets uncertain are done by the users. Convenience and reliability improvements, once the market is established, is done by producers. They're the ones who make it more efficient, lower energy usage, et cetera, et cetera, et cetera. Now, again, why are users the creators of functional novelty? Well, what I told you up to this point is that the market is uncertain and manufacturers don't want to get into it. But there's another piece. Basically, if you look there at the middle line, you'll see that user prototype of the heart-lung machine that John Hashem Gibbon developed. And on the right, you can see that the manufacturers took over, that's a commercial version, and they made the same functionality in a much more commercially efficient and reliable form. But if you look below, what you see is that the entire system of use that the heart-lung machine operates within is sort of unavailable to the producer. The producer makes a heart-lung machine. The person who can innovate within the system of use is the person who actually uses it. So here we have John Hashem Gibbon, and he's basically sort of working out a procedure for clamping the heart, working out a procedure for sewing in the new valves. All of this is beyond the scope of any particular manufacturer of a component in the larger system of use. The only people who have control over the entire system and can innovate by varying different components of it at the same time are the users. Same thing in the case of innovating within the game of tennis. That may be more tractable. So the tennis racket maker controls tennis racket characteristics only. Makes them larger, smaller, springier, less springy, metal, plastic, et cetera, et cetera, et cetera. In contrast, the tennis player, here Roger Federer, controls a complete player system of use. There's a lot more involved than a racket. There's physical conditioning, game strategy, diet, shoes, and all of these things are interdependent. Depending on your game strategy, depending on the type of stroke you prefer, the type of serve you prefer, you need a different kind of racket and different kind of stringing. So the person that puts it together as an interdependent system has to be, again, the user. So next point, It's not that the users just innovate at the start. Users innovate because novel functionality is continually being addressed in a field. So again, back to the skateboard, you see that board there that a person built by, and skate wheels. He basically took a board and unscrewed his or her skate wheels and put them on this thing and had a skateboard. That gave the initial novel functionality, and he could zip around, or she could zip around on this skateboard and see sort of how it worked and what techniques were desirable. However, as the techniques evolved, new functionally novel improvements were added later, like getting air, right? They didn't know they could jump up in the air when they started doing this thing. It took an overhang in the back to do it. You see the middle bottom picture there, you stamp down. And that sort of lifts the whole thing. And then once you know that that's the principle, you say, I need more stamping down room. I'll curve the tips in order to get that different functionality. Again, the manufacturers don't do that because they don't understand the need. It's the user intervening in the middle of the market, in this case, where there is a market already, but a novel functional improvement is added later. So, what is the more complete picture of innovation that we have today? It goes from this, which I showed you before, an arrow involving something entirely commercial, with the idea that only a manufacturer could aggregate demand and spread his costs and so on, has to get it back by patenting and then selling a protected product and the rest. And now we have this. We have, in addition, a different paradigm which complements the producer paradigm. So the producer paradigm, the Schumpeter paradigm that I just described, still exists, and it complements what we have now seen as the user innovation paradigm. Here, it's very much like open source software, for those of you who are familiar with it. The developers are self-rewarded. They're doing what they need to do for their own use or their own pleasure. They post it freely, others collaborate, and then we have peer-to-peer free diffusion. We also have, as those arrows show, connecting the two arrows, the major arrows, we have innovation designs flowing down where producers commercialize them. Now, how do they interact, these two paradigms? As I just mentioned, on the top right there, you see the first mountain bike. On the bottom right, you see the commercial version of that thing. And what's happened is that the designs made by users, as they go down Mount Tamalpais or wherever, are being transferred to the producer. The savings then for the producer are huge. This producer gets basically a vetted design that he can then use to add improvements to. You can also get competition between free products and commercial products. For example, Apache OS web server software versus Microsoft commercial web server software. Now, fascinatingly enough, user innovations can complement producer products and increase consumer value in that way. So what we have here is manufacturers of mountain bikes. They make those. But the only reason that a mountain bike is useful is because there are mountain biking techniques. These mountain biking techniques are what give value to a mountain bike with its special attributes. All of these techniques are developed by users. The manufacturer benefits because it adds value to what he sells, namely the mountain bike hardware. But it's a complement. It's a free complement that gives value to a system of mountain bike riding. Now, because producers benefit from user innovation, they can find it valuable to support user innovators. And increasingly, you're starting to see that. For example, Steam Workshop, put out by Valve, as a way for users to be assisted with tools to develop games, which in turn might then be of value to the game producer, either directly or indirectly. So what you see there is two arrows. You see the arrow of innovation support, namely they've created a toolkit. Coming up from the producer and going down to the producer is valuable game designs. Now, finally, what role can big tech firms like Google play with respect to the new innovation paradigm? First, focus on the types of innovations you do best. What I've described is a division of innovation labor between you and users. The users are the ones who come up with functional novelty. You don't have to do it if you develop a good enough interface to innovating users, and innovating users will do it better. Next, open up your data. We'll talk about that in a minute. Create toolkits for user innovation and help fix the diffusion market failure in the free innovation paradigm. Let me mention each in turn. Open up your data as much as you can. Why? Many eyes can see more in it than any one firm can. So recall Linus's law, given enough eyeballs, all bugs are shallow. You know, I can see it with my toolkit. I can see a different opportunity than all the people at Google could see. And you can see a different one than I could see and the other people at Google could see. And those are valuable opportunities. And if we lock down the data so that nobody can see it, then only some innovations will be found. Now, this is also like Friedrich Hayek, who said, explained somewhat before Eric Raymond, the importance of local information and opportunities that local participants in a market can see or discover. So there's a good understanding that many eyes can see more. Yeah, but can you afford to open up your data? More than you might think. Colleagues and I have done research on this, and firms, for example, that own a bottleneck in a system profit most when everything else in that system is free. So, for example, the bike manufacturer, the mountain bike manufacturer, he wants mountain biking techniques to be free because the user, the biker, the consumer, the customer is only spending as much on that system of bike plus techniques as it's worth to him. So if the technique side is free, that's marvelous, basically. Now, it's also true for other reasons that, when you, like if you think about Linux, if you think about open compute, inputs that are accessible to others that all use in common, also you should open up the data for. Basically, we can discuss this story, but firms in general, lest they make a mistake, they tie down their data too tightly. And you can help a lot by thinking it through and opening up more than you currently do. Finally, you should support the users, as I mentioned. And you want to create toolkits that support innovation by users as they know how to innovate themselves. So it's not just low code or no code. It involves thinking through the innovation process the user goes through and basically giving the tasks to the user that the user does best and do the rest for the user. Okay, so a long ago example of this, Mead and Conway, is if you know about, for instance, gate arrays and custom gate arrays, the intelligence of that system of design, that toolkit, is that all those little things in blue, those are called digital gates. Manufacturers know how to do those. They have no user content in them. There's no reason to give the user tools to develop those. The thing that makes it work is, in fact, the user having a mode of interconnecting these things to make the function that user requires, and that is using Boolean algebra. So you vastly simplify the user task by saying, well, what does the user really know how to do anyway, right? Let's make that available. Now, here's another example that is again more tractable. Think about a deck, okay, an outdoor deck. You've got a deck, you want a deck. What do you know about that deck as a customer? you know what you want to use it for, right? You want to know whether the three people, you know that. You want to know if you want to barbecue on it, you know that. And basically, if the manufacturer gives to you as a design toolkit only the top surface of the deck where all the activities take place, that's what you as a user can innovate in intelligently. And then the manufacturer takes over all the standard stuff involved in making a deck that won't fall down. So they take over the structural engineering. You don't have to know anything about that. That's an example of a toolkit that simplifies user innovation to allow the user to innovate easily on the thing that the user knows a great deal about and wants to innovate on, and automating the rest. So there are other things, lots of other things. I mean, product innovator gender is strongly affected by the suitability of toolkits. Here's an amazing example by Leah Buckley and Mako Hill. On the top, you'll see the standard Arduino board in blue, and almost all of these Arduinos were used by males. Along came Leah Buckley, who's an artist, and she said, well, I'm going to make it so it's tractable for women to do what they want to do, or anybody who wants to do things, for example, with clothing design. So you see that lily pad circle thing on the left? Each of those little leaves is a connection, and you sew to them with silver thread to create circuits. Of those, you can see all of a sudden 65% of the activities were done by women. So, when you're creating a toolkit, you want to create a toolkit that fits the capabilities and the innovator skills and interests. It's a interesting design problem that we're now engaged in. The final thing that I want to mention is you want to help fix a diffusion market failure in the free innovation paradigm. Basically, if you see there on the top right, peer-to-peer free diffusion, users are willing to diffuse what they've created, but they're not willing to work very hard at it. It's a market failure. Manufacturers, on the other hand, if they get a hold of something that others may want, boy, they work really hard to diffuse it because that's how they make their money. Peers say, listen, I created it, you can have it, but I'm really not going to work hard making easy installation scripts and so on for you. So how do they fix that? Well, you can develop AI search tools to help people find these lead user innovations at an early stage. In other words, you can replace the user having to push out information about their designs to a search process. And this is marvelously done now by AI tools that we're starting to get. So today, what we're doing, even with GPT-3, which is at the very beginnings, we've already we're helping basically students in bootcamp entrepreneurship courses to ask questions, and they will get answers back that are somewhat helpful with respect to giving them new innovation ideas. So let me stop there. And in sum, user innovation is huge and growing, huge fun, hugely valuable, and a wonderful area for us all to learn and play together and be productive. So I hope I've stimulated you in that direction. Thank you.
Thank you, Eric. That was, as always, incredibly insightful. And So I want to start off with a question that I often, come across, a tension I sort of often come across in the field of user innovation. So, some people might be listening to your talk and thinking, great, we can just, we're in like a large company, we can just search for user innovations and user ingenuities and just build products that respond to them, or like features that build off these user innovations. But one thing that's really important about your work is that you say companies should not just adopt or appropriate user innovation and sort of shut out the user communities, but to give users continued agency in a truly open system. So can you talk a little bit about why it's important to give give users such agency in system design and not just, kind of search for user ideas and then put them into a closed system?
Well, it's a really good question. And basically, companies, from their own self interest, want to work with users who are continuing to innovate in the field. So, for example, if it's mountain bikes, they want to be connected with the mountain bikers who are doing the leading edge things and so on. And if they just grab, people aren't going to like them very much. But it's also true that one doesn't necessarily know who innovated a particular thing. Patents aren't appropriate. Who made the mountain bike? God knows. It was many people innovating on many aspects. And so the solution that has led to general purpose satisfaction on both sides is when you give back to the community. And so what you will see is companies who make mountain bikes, for example, sponsoring events and paying for these kinds of things in a way that users find appealing. They will feel reciprocity. And it's very much appropriate to the particular area where users innovate. So, for example, Lego puts on, brick fests. They put on these sort of rodeo-like things for Lego builders, and they supply tons of bricks, which the Lego people want more than money, it often seems. So, yeah, you have to think about a long-term relationship, but not necessarily about rewarding particular innovators because it's typically a distributed task.
Right, that makes sense. And if the audience has any questions from Eric, please feel free to put them in the chat in your live stream link. Um, so building off of that, Eric, in your experience, have there been times when this relationship between the company and user communities, sort of gone totally awry, where companies have entered into the innovation space with user communities, and the user community has completely died out, or the user community has responded in an adversarial way to the companies?
Well, Rita, here's where you have to talk about your research. You have a perfect example. Why don't you tell us?
Um, well, Eric, this is your talk, but I'll give some context to people about my question. So a lot of my research has been on mobility platform drivers in Jakarta and how they innovate on they sort of they've built technological solutions to their everyday frictions that they face when they are working on the mobility platform. And so what we've seen is that there's sort of an adversarial relationship set up between the users, in these case drivers, and the companies, where the drivers want, certain things, like they don't want to wait in certain locations because it's difficult, or they want to not accept certain kinds of orders because those orders are inconvenient or unsafe. While users drivers just want to rest, and this is not what the company wants them to do. And so there is this tussle where companies both recognize that the users are innovating because they recognize they are solving some problems, but there is an adversarial relationship set up, so companies cannot just sort of come in and partner with the user community. Then it feels like if the user community they do partner with the user community, there is enough mistrust where the rest of the users will sort of back away from the communities that are partnering with companies. So how do companies deal with uh, this
Yeah.
tension, I guess?
Yeah, well, I loved your example, and where you found the point is, in your case and in many cases, I'm sure, the delivery drivers and the company Gojek, I think it was, right,
Hmm.
were adversaries. Their interests are not necessarily the same. So if you end up with interests that are different, then you'll have an adversarial relationship like the one that you saw that was eventually sort of worked out, you know. So but the for example, the users of mountain bikes, they don't have an adversarial relationship with the makers of the bikes.
Hmm.
Both sides want a bike that's really best for the task.
Hmm.
So There are cases. I remember a lovely case in the a while back where basically people were taking cars like BMWs that were set up for racing, and they were taking out the engine chip and replacing it with an engine chip that got rid of things like the rev limiter. And then they were going like crazy, and then the engine would blow up, and they'd replace the original chip, and they'd go back and they say, I don't know, I was just out grocery shopping, and can you give me a new engine? I don't know. So again, there are adversarial aspects of many relationships, but very often if a manufacturer is trying to supply users
Mm,
who want high quality products, it's much smoother than.
mm, Yeah, that makes sense. And it seems like a large part of it seems like community companies also need to invest in trust building and relationship building with the user community. So it's not a situation where companies can just sort of swoop in. There has to be a long-term engagement with communities.
Yeah, again, it depends on the nature of the
Mm,
relationship and the underlying incentives.
mm,
Again, in your case of food delivery, the incentives of the drivers were different than the incentives of the manufacturer or the company. But it's a really interesting point you raise, because it's often not the case. Their interests are aligned.
mm.
Really good products are what both sides want.
Yeah, that makes sense. So you've you've shown some incredible examples of users innovating for themselves and spending billions of dollars in ways that eventually do benefit companies, but companies often don't recognize these lead users or these early stage innovations. And as you said, producers sometimes actually hamper innovation. So you've worked with a lot of companies, you've had a lot of experience convincing companies to open up their systems. In your experience, what have been some of the biggest hurdles in convincing companies to one, pay attention to user innovation, and two, to sort of, you know, get out of their way and let them innovate?
Yeah. A major factor, interestingly enough, turns out to be that people within the company that are used to innovating based on what they think is a user need input from marketing really don't like the fact that users innovate. They think it's my job.
Mm,
And so, in many companies, and I won't name them, what really happens is giant resistance. I mean, even if, for example, user software, open source software is more valued by the customers than, for example, proprietary internal software, they'll resist like crazy. And it's not just about the money. They're saying, we don't want to start cleaning up user messes. We got here to create wonderful new software. And
mm,
so, again, the incentives of the people inside is to be creative as well as the incentive outside. And so I found that to be a big, big barrier. And it's a work in progress.
mm,
Inside company people have to know that there's an enormous amount to do this creative, and dimension of merit improvements like making them faster, cleaner, neater, smoother. They're technically very demanding too, and so interesting.
mm. Right. So something for all of us at Google to think about for sure. Um, um,
Remember, I went to
okay.
the MIT Media Lab and said, "Listen, you're right at the leading edge of all this. You could put out your projects to users and think of the wonderful thing they do." And they looked at me like, "Are you kidding? I love what I'm doing. I'm going to do it." Yeah.
Um, okay, so I think we have some audience questions. And okay, so Sam wants to know, how does one begin to train the AI system to look for associations or patterns that by nature are novel in order to discover early stage innovation that is widely distributed?
Yeah, we really need your help in that. What we know how to do at this point is we look for, and GPT-3 gets around this, it's just straight text. But what we have done is basically say we're looking for queries out there or comments in user groups on the web that say things like, I created, I solved a problem. And then we're looking for those where there's uptake. So,
Hmm.
for example, when you have a new innovation in kite surfing, you'll start to see somebody saying, well, yeah, I did this and that and the other thing and describe it. And then you'll start to see other people talking about it. And that typically is the data signal we've looked for that has legs. Now, we've been able to ask GPT-3, which I know is going to be supplanted soon. We've been able to ask it what are non-commercialized innovations in, for example, kite surfing, and it'll list some.
Hmm.
Now, the students then have to do more work to vet it and make sure it's not in the least fully reliable. But boy, if we could get something that was marvelous and text driven instead of, all sorts of analysis driven, we'd love it. And I think we should be able to. I hope so.
Hmm. Hmm.
That's what we're relying on you for.
Yes, well, if anyone wants to partner with Eric on building something like that,
We need it.
please reach
We
out to
love
him.
it. The universe would applaud. Yeah.
Yes, yes. Yeah, and so that's really interesting. And I just want to add on like a side question to what you just said. Are there specific, if someone was interested in building a system like this to search for user innovations, are there specific online communities where these conversations are happening, or are a lot of these conversations happening offline?
Well, we're really pretty early stages now, but among academics, we're chatting about it.
Okay,
Um, but I don't know that companies are yet.
okay, okay. Okay, I think we have another audience question. So Nicola says, Eric, read your books. They provide inspiration. Do you see more innovation as grassroots with resource constraints in the inventors, or from underdog innovators who want to challenge the status quo?
Well, there's a mix. Some people, I mean, we have also, that's a great question, and thank you, Nicola. So sometimes we see questions where people are saying, I just want to do something that's really fun, like try to figure out how to get a supercomputer into an Altoids tin, something like that. And then it's a technical challenge. But what we're really seeing in the UNDP thing, which is just marvelous, uh, we're seeing, for instance, huge system level innovations because they have to. So, for instance, in Bangladesh, now a large part of the country is 30% of the year underwater. And they can't really plant their farm fields as they used to be able to do. So they're inventing an entirely new system of floating fields. And in between the floating fields, they have fish pens with just cheap mesh and duck pens with cheap mesh. And they get an entire diet out of a system level innovation becoming aquatic. It's incredible. So it's not only, and they're driven by need, but the point is, again, as I earlier mentioned, there are a lot of system of use related pieces of that. And so they're working like crazy to survive and doing marvelous things. And that's what we see a lot in the UNDP.
Um, yeah, so that's interesting. I mean, there's obviously like a wide range of innovations that you see in globally across the world. A lot of them, those seem to be sort of small scale innovations, like a sort of a community resolving or a user resolving their um, individual problem. But at a lot of large companies, we sort of want to build for scale. Uh, do you see a tension between the scale at which user innovation exists and the scale at which these like global products want to be?
Well, I look at it slightly differently. It's a very good thought, but I look at it differently. Uh, when somebody talks about the Industrial Revolution, for example, right?
Mm,
That was important. Oh boy, that was important, right? But when you look at it in detail, it consisted of somebody making an automated belt maker and somebody else making a light that had a switch and lots of little components.
mm,
So what the firms have to do, and my example again about becoming aquatic, what the firms have to do is say these are pieces of a larger system. So each
mm,
piece we could potentially use or build on or so on, but we also have to pay attention that there's a massive opportunity here. Just think about the opportunity if we're saying that a significant fraction of the world is going to go aquatic.
mm.
You know, these same people, they have put schools on boats, and the boats go up and down the river, and the kids learn until it hits their stop point again, and so on. I mean, just marvelous stuff. So, system.
Yeah, yeah, yeah. And I really love the how you frame the system of use thing, where companies are also just one piece of the puzzle, right? Because one
Yeah,
company only understands one part of the system of use.
yeah, and they that's fine. Then they leave the task, the larger task, to the users, which is perhaps appropriate. But they can peel off big chunks like tennis rackets in the case of
Hmm.
that one, and so on for themselves. And
Hmm.
that's what successful businesses consist of, really. So,
Yes, well, thanks, Eric, a lot for everyone to think about. This was, as always, educational, insightful, incredible examples that you always give. And thanks so much for sharing your expertise with us and giving us your time.
delighted to do it anytime and pleasure. Thank you, Rita.
Well, thanks, Eric, and thanks everyone for joining us.
Okay.